Let's do an example using the lens equation that we have derived. Find your handout from class called How Are Images Formed? And we're going to use the lens equation to find the image distance and see how it matches up with our diagram. So looking at number 1, the givens were the object distance and the focal length. So the focal length was 1, 2, 3, 4, 5, and let's suppose a scale of 1 centimeter per square. So the focal length would be 5 centimeters. And the object distance, it was 8 squares away, so that would be 8 centimeters. And let's write our equation. We don't have a lot of space here. I think I'll do it right over here. So 1 over the object distance plus 1 over the image distance equals 1 over the focal length. Substituting, we have 1 over 8 centimeters because our object distance was 8 centimeters. And remember that object distance is always positive. Plus 1 over di equals 1 over the focal length. Focal length is also always positive. And using our calculator, let's find the image distance. So I'm going to have 1 over 5 minus 1 over 8. Which I'm going to do as 5 inverse minus 8 inverse. And then I'll need to take the inverse of that answer to get di. So the inverse of the answer is 13.3 centimeters. And let's see how that matches up with our diagram. 5, 6, 7, 8, 9, 10, 11, 12, 13. My diagram looks maybe like 13 and a half, so 13.3 is a good match with the diagram. Now turn to the back side and let's do an example that involves a virtual image, because that's where we're going to see a negative sign for the image distance. So our given values, once again, we had 5 centimeters for the focal length, and here the object is between the focal point and the lens, and that object distance is 3 centimeters. Always positive, and we're looking for the image distance. Writing down our lens equation, 1 over do plus 1 over di equals 1 over f. Object distance is 3 centimeters. Focal length is 5 centimeters. Solving this for 1 over di, I have 1 over 5 minus 1 over 3. So 1 over di equals 1 over 5 minus 1 over 3, negative 0.1333. Taking the inverse of that, we have negative 7.5 centimeters. Okay, so the 7.5 tells us how far away from the lens. The sign tells us which side of the lens. If actual light rays intersect, we will have an image over here, and the image distance will be positive. I think of it as a positive number, means that's where the thing is supposed to be. So actual light rays are over here, so this is where images should be. If it's on the other side, where the light rays are not actually intersecting, it's going to be negative. So let's see, negative 7.5. 5, 6, 7, negative 7.5. So that's exactly where we find the image.